Welcome, everybody. Just going to wait one more minute and then we'll start. I'm counting us up to about 50 people so far. And again, we had over 100 registrants. Okay, I think we'll start. My name is Ian Shapiro, and talking to you from my new position at Syracuse University. Some of you know me. I worked for many years at Tatum Engineering in Ithaca, New York. So at Syracuse, I'm professor of practice in mechanical engineering and associate director for building science and community programs at the Syracuse Center of Excellence at Syracuse University. Today's webinar, I'm so excited, opportunities for innovation for heat pumps. And so with electrification being a major component in the pathway to decarbonizing, heat pumps lead the way for electrifying space heating, domestic hot water, and then specialty applications, clothes drying. And we're going to have a kind of a lightning round today with 3 experts speaking, and they've been asked, what do you see a need for? And that's what they'll be speaking to. These are 3 people who have a ton of experience with new products in electrification, with heat pump products. Before we start, I'm going to make a few quick announcements. Next Wednesday, February 6th, we'll be hosting a research and technology forum, 3 to 4 p.m. Dr. Peng Gao from Syracuse University will be speaking on research on urban geospatial patterns and the nexus to the built environment, followed by Dr. Lu Li speaking about Green Design Studio software, integrated software for indoor environmental quality, comfort, and energy. That's next Wednesday, February 6th at the Syracuse Center of Excellence. There'll be a registration link in the chat. These are wonderful forums that we host, and a great place to learn, great place to meet people. It'll be followed by a party. So it's our New Year's party, just a little late. So feel free to join us, it's open, but you do need to register. Another announcement, the EPIC Buildings deadline. EPIC is the energy program for innovation clusters. It is the program that I'm leading. It's a DOE program, and we have a specific set of 3 initiatives with a deadline of tomorrow. So if you're with a startup, we have an accelerator program. We have a small-scale prototype program. Over the summer, we will help you build prototypes. And we have a fabulous intellectual property program, all based at SU. The accelerator is based at the Center State CEO downtown Syracuse. Deadline is tomorrow. There should be a link in the chat. Again, any of you startups interested in support for your projects, this is a great program in its 3rd and final year. So I think that covers the housekeeping. Thanks to the Department of Energy for sponsoring this event, the Building Technologies Office, and the Office of Technology Transitions. So let's get into it. Opportunities for innovations. Our 3 speakers today. Nicole, Ceci, I have their bios, and usually I would read the bios, but I find that kind of boring. So I'm going to tell you kind of what I know about these people. Nicole Ceci, with the undergraduate and graduate degrees in engineering from Cornell, started her career at Tatum, and today is principal mechanical engineer at Stephen Winter Associates in New York City. And Nicole's career just took off, and she has a specialty in domestic hot water heat pumps and domestic hot water in general. And today she is my go-to person for domestic hot water. I'll first stop by and talk to Evan a little bit and a few people in our office, but then if I want serious answers to these questions, I go to Nicole. So excited, leading a lot of demonstration and research work in this area. Jordan Dentz is a vice president with MaGrann Associates, and he has a bachelor's and master's from MIT. And I know Jordan on these demonstration projects. I'm frequently emailing Jordan with questions. What is he seeing in heat pumps? He led a large demonstration project down in Brooklyn, and retrofits, heat pump retrofits. And it's a delight that Jordan joined us today. And then finally, Evan Hallis from Tatum's office, senior energy analyst with a degree environmental studies or environmental science from the University of Vermont. And Evan has won a national award a few years ago as, oh my gosh, 30 under 30 or something in building science. Evan is another go-to person. There's a reason I invited these three professionals to this forum. Evan is another go-to person for me, and he is familiar not only with heat pumps, but also with envelope issues and the interaction between envelope and heat pumps, and he's a real advocate for quality building science work. That said, I'm going to turn it over to the panel. They'll each make a presentation. We'll hold questions for the end, but don't hesitate to put questions in the chat. They'll make presentations and we'll have time at the end for questions. Take it away. I forget who's first. Evan, you've got the slide deck. Jordan is going first. Thank you.
All right.
Okay, thank you, Ian, for that magnanimous introduction. I know there's a lot of people on this webinar that are more knowledgeable than I, so I hope I can live up to your expectations. Thank you for the slide. So just quickly, MaGrann Associates, we're building consultants, high performance buildings and certifications, serving most of the Northeast, and I'm the vice president and manager for Building Performance Solutions, which is the existing building group. Let's go on to the next slide, Evan. So, thanks. I thought it would be useful before we dive into our wish lists for opportunities for new heat pump technologies and features to talk a bit about some of the activities that forward-thinking agencies have been engaging in the past few years, doing just this sort of thing, pushing the industry towards developing new technologies. So I'm just going to spend a couple minutes on that before diving into what I see as additional product needs. And so Evan, go to the next slide. NYSERDA has been very active in this. They are really, for the past 7 years or more, have been pushing industry to develop a variety of new technologies. A lot of the work that I've done has benefited from their foresight and their support. Looking for products with higher efficiencies, integrated heat pump water heaters with space and water heating, things like energy pods, which are modular solutions for heat pumps, cold climate package terminal heat pumps that can swap out for all the PTHCs that we have throughout New York City and New York State. Mini split heat pumps that fit into PTAC sleeves, which is a pretty interesting idea. Community heat pump systems, refrigerant related work, and of course low global warming potential refrigerant. So they've been funding a lot of these activities, and we'll talk a bit about some of the successes. Next slide, please. In addition to NYSERDA, NYCHA, in partnership with NYSERDA and NYPA, their power authority, has also been active in encouraging the industry to come up with, in this case, a specific solution to serve their needs with a lot of features that not only can benefit the product that they are interested in getting out there, but other products, things like equipment that works on standard plug-in 100-volt, 115-volt sockets, operates down to the temperatures that we need without resistance backup, solutions for drainage that don't require a plumber, easy to install, without refrigerant connections, quiet and cold climate efficiency units. So they've been pushing the envelope on that as well. Next slide. And there's been progress thanks to these efforts. I mean, we now have over the past 5 or so years, whole host of new products enter the market that solve some of these requirements. We have a mini split that fits into a PTAC sleeve. We have this slim packaged wall mount type heat pumps, and soon we're going to have up to about 5 manufacturers of a product of that configuration available. We now have cold climate PTHPs. There's even a company now starting up with modular energy pod type solutions. And of course, we have, as you see, 2 pictures here of the window units that NYCHA has been encouraging to be developed and has supported the development of and are being demonstrated now. Those through window saddle type units. So a lot of progress and products out there now. We're going to talk about some things where there are still holes, where there are still additional needs and opportunities. So I'll rattle off a bunch of them here in the next few slides from my standpoint. And this is disclaimer. This is just what I see as need, and I know that we're going to have some overlap between myself and Evan and possibly Nicole, but that's okay. So one need that we've seen in some of the work that we've done is smaller capacity units that are suited for apartments. This is an example of some load calculations for a NYSERDA study where we surveyed a number of buildings, and these are the loads in the rooms. So getting down to the 3 to 5, the 3 to 6 kBTU per hour range per zone. We still don't have products that are either packaged products or multi-split products that are in that range. Next slide, please. I mentioned that there's now a cold climate heat pump that fits into a PTAC sleeve, but there's also a lot or even more room air conditioner sleeves, which are a little bit smaller, so a little more challenging, but that's another great market and opportunity. And by the way, those sleeves should be thermally broken and insulated. And I think there might be some products out there, but I don't think they're widely known or available or used. We want to, if we're using sleeves, make sure our envelopes are not compromised by them. Next slide. One of the key features that when I first started looking into cold climate heat pumps many years ago, kind of surprised me a little bit. Like one of the major stumbling blocks was the draining of meltwater in winter. And now these products that NYCHA is using have features to disperse that water without requiring plumbing. And that feature is key to making those products a success and would be needed on other products as well in order to keep the cost of installation down. Also on this slide, diverging, this is the only heat pump water heater I'll mention, but the split heat pump water heaters that we now have are great. There's of course the Sanco product, but it's a little pricey for many applications, and there are lower cost products out there in the world overseas that we can get them here and make them suitable for cold climates. I think we can make a dent in electrification of homes where hybrid systems are just not practical because of space constraints or other issues. Next slide. integrated heat pump water heaters, one of the NYSERDA goals. I still think that's important and have not seen products widely available for that yet. Also suitable for hydronic conversions as a plug-in substitute for a boiler. I know that Tatum did a demonstration evaluation of those recently, and the technology we're lacking. So we're hoping that there can be improvement in that area. And another feature of heat pumps that I know Evan's going to talk a bit more about, so I won't dwell on, is refrigerant connections that are reliable, easy to make, don't require licensing, and will enable quicker and installation by lower skilled tradespeople who can be installing these heat pumps, because we're going to need a lot of people to do that work, and it's important that they be able to do it reliably. Next slide. One of the big issues with electrification, of course, is the electric service, and trying to avoid the need to spend a lot of money on upgrading electrical service. And I wonder if there can't be controls technologies that will enable us to minimize the need for electrical service upgrades by cycling units to keep demand at below a threshold. And also on the controls side, for multifamily affordable buildings where the landlord is paying for the heat and is required to pay for the heat but not the cooling, being able to shift that cooling cost on to the tenant with a utility grade metering or an acceptable metering solution built into the units would be helpful. Next slide. And I think that's the last of my slides, Evan. We're trying to go quick, so we have a lot of room for discussion later. And turn it over to you.
Great. Thanks, Jordan. And thanks, Ian, and everybody for attending today. So I just want to take a moment to reiterate a little bit Jordan touched on. There's been a lot of movement in the market the last several years, which is awesome. And so we've had the opportunity to work with some new products. We're excited about some products we've seen recently. So I just wanted to acknowledge that some of our needs and wishes here today may actually be in the market, but they're not fully at scale yet. And so I just want to kind of give a nod to that, and a thanks to the manufacturers and the folks who have been working hard on that, such as NYSERDA and NYCHA and NYPA. And we're excited for to still meet some of the needs that we need over the next several years. And some of what I'm going to talk about is a little bit what Jordan touched on, but I think it's good to reinforce from our perspective. Tatum's does a lot of work upstate, a little bit colder than kind of New York City and the Mid-Atlantic region, and we're seeing very similar issues up here. And some of what we also need is what Nicole is going to talk about. So I'm not going to touch on domestic hot water, but I fully support what Nicole will talk about next. So kind of going back to what we're seeing in the field, Jordan talked a little bit about some of the projects that they've done some load calcs on, and mentioned the need for kind of some smaller capacity systems. We're seeing the same thing. So on some of our new construction projects, specifically in the multifamily sector, we're seeing loads that are very, very low. So even projects that maybe aren't pursuing passive house, but are approaching that kind of level of performance, some of our loads are on the magnitude of 4,000 to 5,000 BTUs per hour peak heating loads for an entire apartment, a one-bedroom apartment. So per room, that's even below 3,000 BTUs per hour. So very, very low loads. And some of the traditional split system heat pumps, like a multi-split heat pump with a ductless wall cassette in each bedroom, in each living room, are dramatically oversized. And in some ways, it's really fortunate. We feel like the industry has scaled up. There are a lot of contractors who are becoming more familiar with ductless split systems and installing them. But unfortunately, a lot of them are now oversized, and we see that as a potential limitation to fully scaling these electrification efforts. So kind of as Jordan mentioned, we agree, smaller capacity heat pumps are needed, both smaller fan coils, but potentially smaller compressors and refrigeration systems, circuits for split system, whether that be multi-splits or even VRF systems. We've even seen similar, issues on the water source heat pump side. So we've worked on a couple ground source heat pump projects, and we were able to get water to air heat pumps that are water source heat pumps that maybe are designed for our peak loads, but they don't have features that we would like to have on those types of systems, like ECM fans, hot gas reheat for dehumidification. So some of the features that we like to see are not available on those small on those small water source heat pumps. So that there's an opportunity to kind of bring some of that technology to the smaller equipment. And then the room heat pump products, which we're really starting to see a growth in, which is really exciting. And there's some larger capacity systems, but we're really seeing an opportunity too for these 3,000 to 6,000 BTU per hour systems that could really be that single package product per room, whether that's a living room or a bedroom in a multifamily building. And so I just want to kind of touch a little bit further on the room heat pump products. So as Jordan mentioned, and I'm showing here again, there's a couple products that are in development through this NYSERDA Clean Heat for All Challenge, which is super exciting. That was focused on products that could go over a windowsill, so could be installed in a double hung or a single hung window, which is excellent because obviously there's a lot of buildings out there with that type of window typology. But I do remain a little concerned about some of the air leakage and the functionality of that window long term, and kind of the thermal performance of that type of situation. So I would really love to see this type of application adopted for kind of like more of like a split system, a really small split system. So the photo in the top left was an EcoSnap product that NREL was working on several years ago, which I think kind of fizzled out. What is all around these quick connections for the heat transfer fluid, whether that be refrigerant or a different type of fluid, and electrical and control wiring between the outdoor unit, which you could mount directly on a wall, maybe below the window, and then the indoor fan coil, which could get mounted on the indoor wall below the window. Several of the projects that we've worked on, we're looking at doing window replacement, and we'd really like to eliminate the single hung or the double hung windows and move to something a little bit higher performing, like a casement, a tilt and turn, maybe an awning or a hopper. But then that limits us in terms of the ability to maybe use one of these products that goes over the windowsill. So another option here might be to reframe the rough opening at the sill, and provide a passage for that heat transfer fluid piping, and the electrical and wiring to connect the indoor and outdoor unit. So it would be great to see some of these window products get adapted for that type of situation. And then also you could always go through the existing wall assembly. But there's always some limitations there when you're drilling through an existing wall assembly. Another thing that we've heard from some of the manufacturers on the refrigerant-based systems, so some of the split systems, VRF, we're pushing them to make smaller and smaller equipment. And I think there is some limitations there. I'd like to see it happen, but maybe there's some opportunity for us to move away from some of the refrigerant-based distribution systems that can solve a couple problems, some of the small equipment issues, but also it gets rid of all this refrigerant piping in the field that has potential for leaks, which can impact performance, but also can release the high global warming potential refrigerants. So one option is to move to a water-based solution, so a monoblock package heat pump product that's an air-to-water type of system. But there are some in the market, which is great, but they're limited in the rated capacity, and the efficiency tends to drop off pretty good at colder climates. So really encouraging more cold climate air-to-water heat pumps in the marketplace, and just having those options available for projects that can use them. Another area that I spend a lot of time working in is in ventilation. So we've been moving away on all of our projects, and in general, the industry is moving away from gas-fired rooftop units or gas makeup air systems, or even gas tempering of air after an ERV. So oftentimes after an enthalpy core or an enthalpy wheel, the discharge air back into the building is still maybe 58 degrees or 60 degrees. And some projects demand that get brought up to at least to neutral building temperature. So something like 70, 68 or 70 degrees. And historically that's typically been done with gas. But recently we've been moving all our projects to electrification, to all electric. And so we've been looking at heat pump options to do that tempering of that ventilation air. And there are some products out there. Several years ago, they were limited. There's a few more now, but there's still some lack of cold climate options. So like some of the equipment that we've specified in the past has cut out the heat pump at about 10 degrees Fahrenheit. And up here in Ithaca, our design day is around 0 degrees. And so what happens, we end up having to size these large electric coils. And so we're having these large peak loads of electric resistance heat when we most want to be using heat pumps. So love to see some more ventilation solutions that are utilizing heat pumps, specifically cold climate heat pumps. And then lastly, this is a picture of the Center of Excellence. This is a conversation that Ian and I have had. Give Ian most of the credit here, but I want to kind of bring it to the forefront. I think there needs to be more what I call quote unquote real world performance testing. So it's not laboratory testing that all the heat pump manufacturers are doing when they're certifying their equipment. So through AHRI standards or going to an Intertech lab, and it's not the work that we're doing in some of the demonstration projects where we're kind of doing maybe utility bill analysis, maybe we're doing some more detailed M&V, but there's a lot going on in the actual field studies. So we've been seeing some of the field studies come back and the results of heat pump performance are kind of all over the place. And I think there's a real opportunity to do more kind of real world performance testing, but in a lab setting. So we're not just doing steady state testing, we're almost setting up an apartment or a house in a laboratory setting and testing different conditions over longer periods of time. And I think that would be a really good opportunity to really evaluate things like the impact of oversizing heat pumps. So like multi-splits in the field data that we're seeing are coming back much less efficient than one-to-one units where you only have one outdoor unit for one indoor unit. But it'd be really nice to study that in a more controlled setting and then compare versus like a ducted system, for example. So we've got clients, and we've got projects where you look at the performance on paper, the multi-splits look better, but we have a lot of concerns that given that they're being oversized, that their performance is going to be much worse. So I think that this is a big opportunity for industry to look at closer, whether manufacturers can get involved here, whether it's organizations like the Center of Excellence. It'd be really interesting to get some funding to study this type of real world performance a little bit closer. And that could be everything from split system heat pumps to package heat pumps to air to water heat pumps. There's a lot of opportunity here to test different products. And other things like impact of setbacks, right? There's the whole thought of once we move to a heat pump, we move to set it and forget it. But is that the best approach? What determines whether that's the best approach? Is it you're gone for 4 hours, you set it and forget it? What if you're gone for a day? What if you're gone for 2 days? Does it matter if it's 30 degrees out or 0 degrees out? And just studying the impact of that a little bit more in a more controlled environment. And then things like defrost and base pan heaters. There's base pan heaters that are operating in sometimes unknown amounts, and it'd be interesting to study how much of that is actually impacting the overall efficiency. So lastly, there's just a couple other additional needs. Some of this is repeat and some of it is not listed here, but I just want to stress what Jordan was mentioning in terms of a non-piped defrost meltwater condensate disposal solution. So that's going to be really critical to keeping costs down and keeping complexity down on these retrofit projects. So I commend the folks who have been working on this, and I encourage folks to continue to work on it. And hopefully we can come up with some solutions that really allow us to continue to grow these retrofit projects. Also integrated equipment that would have heating, cooling, ventilation, and domestic hot water, kind of all integrated into one package, but that fits into like an apartment size mechanical room. So that, either on a new build or an existing project, that could be used. And then this is kind of a little bit of a outside of maybe a heat pump manufacturer, but it's tied into heat pumps. But every project that we work on, it seems like when we talk about split systems, mounting split systems on roofs, there's no like perfect solution to how to do that. And it feels like there needs to be some innovation in that world in terms of supporting the heat pump stand, so we're not having to penetrate the roof membrane or cause thermal bridging in the roof assembly. I'd love to see some innovative solutions there, maybe like a ballasted type like solar PV is using. So without further ado, I'm going to go ahead and pass it over to Nicole to talk about some other good stuff.
All right, thank you. So I'm with Stephen Winter Associates. I'm out of our New York City office. We work kind of up and down the East Coast, mostly from Boston to DC. Next slide, please. And so, you know, we need to decarbonize our buildings, and decarbonizing our domestic hot water loads in those buildings requires us to have some really great heat pumps that we can rely on to get that job done. Next slide. Thanks. So before I get into the details of what we need from those heat pumps, I want to kind of make sure everyone is comfortable with the concepts that are kind of at play in the background here. So starting with what is a DHW, or domestic hot water heat pump. A heat pump in general is something that is pulling heat from its surroundings and pushing that heat somewhere else. So a refrigerator, for example, it's pulling heat from inside that refrigerator to keep it nice and cold inside, and pushing the heat from the refrigerator out the back of the refrigerator just into the surrounding kitchen. So that's a heat pump that a lot of folks have a lot of familiarity with. So in a domestic hot water heat pump, heat gets harvested from the air or the water, wastewater, whatever that source is, and pushed into potable water for domestic use in the building. That's done with using electric compressors and valves to move refrigerant around in a circuit. And that refrigerant gets evaporated and condensed in key places around that circuit to absorb heat, release heat, and move it. And it takes power to do all that. It takes power to move that heat and run that refrigerant cycle. But you end up with more heat at your end goal, at your end point in your domestic water, in this case, than energy you put in to move that heat. So your efficiency is over 100%, which is why we're excited about these. Next slide. So to set the stage and give some context for what I'm speaking about, I work largely in New York City multifamily retrofits. That's the market that I spend most of my time in. And those buildings tend to have central domestic water heating plants. So the constraints of that particular market are the ones that are highest in my mind. Decentralized systems, they also need a lot of innovations as well, but I'm going to focus mostly on the central systems today. And some of the points that I'm going to touch on are going to overlap between the two anyway. Next. So this market, specifically domestic hot water heat pumps for larger multifamily applications, is extremely underdeveloped. We work on, as a firm, we work on a lot of different passive house construction projects, and those buildings, they tend to pursue electrification of almost every load: heating, cooling, laundry, cooking, you name it. But when it comes to domestic hot water, they often stick with gas-fired equipment for that load. And these are our clients who are really pushing the envelope, and they're trying a lot of new things, but many of them aren't even convinced to go to heat pumps for domestic water heating just yet. So we need some good options on the market, and we need some problems to be solved, some innovations to happen to really get domestic hot water electrification to take hold and scale up. Next, please. So I'm going to run through some of the high points on my wish list for this market. So to meet our carbon reduction policy goals, we have to electrify domestic hot water production in a really wide variety of buildings. And electrifying that many different buildings means that we really do need diverse solutions. And I'm going to jump right to the larger kind of commercial grade split systems for central water heating, because that's what's needed for most bigger multifamily applications. And it's the world that I spend most of my time in. In this market segment, in this product segment, most commonly we see water piping going between an outdoor unit, and that's harvesting heat from the outdoors, pushing that heat into the water piping. That water piping then connects to a central plant, a tank, an indoor unit, some kind of component inside in the central plant, and that receives that heat. So heat's pulled from outside, pushed into that water loop, and sent into our central plant. And any solution that we're using needs to work in our climate, which gets cold. I have had domestic hot water heat pumps freeze and burst in cold weather on my projects. It's not great. Most of the products that are available today for this market segment are running water piping between those outdoor units and the indoor plant to move the heat. And really only a few options use something freeze-proof like glycol or a refrigerant. And in my opinion, that needs to change. Water freezes in freezing weather. It's driven to freeze in freezing weather. That's just kind of nature. And it's really a lot better to have a product that is intelligently and cleverly designed to prevent freezing than to rely on a lot of engineering belts and suspenders to try to fight the natural tendency of water to freeze in cold weather. So that's number one. They need to be freeze-proof. That's something that I have number one on my wish list. Number two is that water needs to be safe. We need to design for safety. And that means not ignoring Legionella risks. Typically, that means that we need these heat pumps to generate water at a high enough temperature that any storage tanks we're using are sitting above the thresholds for bacterial growth. You could also accomplish this by using a system that stores heat in another form, like a phase change material or some kind of non-potable fluid. But none of the big heat pumps on the market today support this. They're all really designed to be working with a large quantity of potable water being stored in tanks that cross through a variety of temperature thresholds, including crossing right into Legionella growth zones. So, I have a note up on the slide here that this is a contentious criteria item. And that's because there are a lot of designers out there who believe that no one gets Legionella or different infectious illnesses from hot water, domestic hot water systems. A lot of residential, like single family home water heaters across the country sit at pretty unsafe temperatures, at bacteria friendly temperatures, you could call them. And there are not a lot of cases of Legionella based illnesses diagnosed in the country. And so that leads a lot of folks to argue that the potable water storage temperature is not a big deal. That shouldn't be a design paradigm. But I am the one speaking today, so I get to tell you my opinion. And my opinion kind of comes from reading work by OSHA, World Health Organization, ASHRAE, American Society of Plumbing Engineers, and others who all kind of point to, they all concur that bacterial growth does occur in lower temperature water, and that's a problem. So I consider that having heat pumps and getting heat pumps on the market that can operate at those high enough water temperatures, or maybe with a non-potable fluid, I consider those product needs to be of very high importance. And the last item that I've got in my big three is efficiency. And it really hurts me to have efficiency be at the end of my list as a sustainability professional, but these are all critical needs, and I think safety and functionality of the system are more important than efficiency. Efficiency is very high on the list, though. We can't waste energy, of course. And we also can't drive up operating costs so high that decision makers choose to stick with or go with fuel-fired products instead of using heat pumps. Because that's exactly what I see happening in the New York market, in the New York City market right now. Even with the climate legislation in place that we have, the economic argument against using heat pump water heaters that are available today is pretty strong one, and that really needs to change. Next slide, please. So those are my three biggest needs in the market, and after those three, there's a lot more. One of them is looking at the refrigerant that the heat pump is using. So refrigerant itself contributes to global warming when it leaks. It contributes to climate change. It acts like a greenhouse gas. GWP is the global warming potential, and that is the kind of equivalent impact of a given refrigerant in terms of pounds of CO2. So 1 pound of R410A is equivalent to over 2,000 pounds of CO2 being released. And that means that if you leak some of this refrigerant, it really counteracts the savings that you're making from electrifying and decarbonizing in the first place. And a lot of these refrigerants are being phased out right now and over the next couple of years in New York and nationwide, but there are not as many replacement technologies for manufacturers to fill the gaps as we would like to see. And it means that what was like already a pretty small selection of products in the market is shrinking a little bit. Next, please. One other thing I wanted to call out is that we need these units to operate really well when it gets cold out. So this graph shows us an example of a heat pump water heater's performance dropping off as it starts to get cold out. The heating capacity, the output capacity dropping off as our outdoor air temperature decreases. And this graph only shows us down to 45 degrees outdoors. That trend, that drop off continues as it gets colder and colder. A lot of heat pump water heaters also lose efficiency as it gets cold out. So capacity and efficiency tend to drop off. Now, there are a lot of products that work in cold weather. They work, they function. But having a piece of equipment that functions so differently at different outdoor air temperatures just makes it really challenging to design and operate a plant like that. And so I would love to see a more stable product that sort of operated more stably across a variety of outdoor air temperatures. And I think that would decrease the cost of plants and increase the uptake of electrified domestic hot water. Next, please. And my final pitch here is that a lot of engineers, we forget the basics, and we see our clients asking for kind of a product or a black box solution for decarbonization. And I think if we could find a way to kind of simplify and market smart load reduction strategies as well, that would have a really big carbon savings impact. There are a lot of simple things that are not as exciting and not as flashy that we can do to really drive a lot of carbon savings, like low flows and different plumbing layouts and recirculation design improvements and wastewater heat recovery. And a lot of this work, it needs a non-technical innovation, but it still needs a really big innovation to drive market uptake. So I wanted to make sure that that didn't get left off the table, and I would love to see someone come up with a solution to drive uptake for load reduction as well. All right, thank you. I think that's my last slide.
Thank you, all of you. Such a stimulating set of lightning talks.